Okay, so I'm going to go over your science study guide and all the vocabulary that's going to be included on your test. So the starting page, and this is going to be found on Schoology. I'm also going to upload this video on Schoology and on YouTube so you can access it through any mobile device. So the essential standards for science to get ready for your science EOG. First, we're going to look at force and motion. So position is the location of an object. So always when we're working, remember back to your PBL that where was it starting? Which direction did you want it to go before the force was acted on it? You need a position, so where it's located. A reference point, any object that is not moving and can be used to describe the position of another. So you have to think, whatever you are using, you could measure how far the distance between from where your car started to where it ended based on things around it. Our reference points could also be like I went 1 mile past the McDonald's. My reference point was McDonald's. Distance, the length of a line between two objects. So in math, we do between points on like coordinate grid where you're trying to find from here to here. We also have distance and how far an object has traveled to from its starting point to its end point. Motion, a change in an object's position. For force and motion, the motion piece is when it changes its position. Back to the definition of position, where it's located at. So if it was at point A and it's moved to point B, that change in position is motion. Direction is the path that a moving object follows. So once a force is acted on it, it moves in the direction that force has pushed or pulled it. Speed is a measure of how far an object moves in a certain amount of time. So you're thinking distance divided by time. In speed, don't confuse speed with acceleration. We're going to get into acceleration and deceleration soon. But speed, how far an object moves within a certain time. Like if you think 50 miles per hour, it's called miles per hour because you can go 50 miles within 60-minute time frame. You're also going to have within your test like graphs that are shown on here. A constant speed, you can see on our graph that it consistently goes up. Increasing speed, you have the dip, and that is because it has accelerated quickly. It's increased, so you can see the change here. In constant speed, it's kept that constant growth, constant speed of like accelerating at 2 miles per hour, whatever would be considered within the graph. Decreasing, I'm not sure why it's not showing up on my screen, but you would see that it would be the opposite of increasing. It would be dipping down. So the top piece would be closer to the origin at the top and move down. Force is a push or pull on an object. Remember back to when in my small group we were pushing and pulling on the table? Objects move in the direction of the applied force. So if I'm pushing on a table, it will move in the direction I'm pushing it. If I'm pulling on a chair, it will go to the direction that I am pulling it. A force can change the direction of an object's motion and the speed. Think about it like in a car accident. If it hits, it can change it and it can push the car in that different direction. The greater the force, the greater the motion. So when more force is applied, the greater the motion. Think more force applied, the farther a chair can be pushed. The greater the mass, the less motion. So remember back to when you built your cars with Legos, you need that shorter mass. I mean, not shorter, sorry. That less mass to get a farther distance, to have more motion. That's why you were changing out the wheels on your car or changing the blocks, because if you had too much mass, it slowed you down significantly. Objects that weigh less can move faster, and we realize that within our PBL. Mass is how much matter makes up an object. So it can be within it, but we want to think about similar to weight, but the amount of matter within the object. And it is measured in grams if we go back to math. Matter, anything that has mass and takes up space. So that's when we get back to that object that takes up space is going with matter and mass. Gravity, a force that pulls objects towards each other. So if we're saying objects like us, for example, and Earth. Gravity is pulling us towards Earth. Those are our two objects, us and Earth. So if we throw a ball in the air, it's going to go up at a constant speed and then slowly, because of the force that's going on it, and then it is going to stop and it's going to fall back quickly because of the force of gravity acting on it. It will fall to Earth quicker than what it had went up to go against the force of me throwing the ball up. So again, the more mass an object has, the greater its pull of gravity. So heavier, the greater the pull of gravity. The closer two objects are, the stronger the pull of gravity. Friction, the force that acts against motion, causing objects to move slower and eventually stop moving. So just like when you built your cars for your force of motion PBL, you changed your tires around and eventually your car would stop rolling because of the friction on whatever surface you used, whether that was concrete or the floor or the carpet. Different materials had different amounts of friction, just like in your simulation between the tile floor and the sandpaper. And if you do, like your hands rubbing together, that makes friction. It's also a form of conduction. Okay, looking at matter and energy. Within matter and energy, we have heat transfer and the water cycle. So looking at the review of the water cycle, the movement between Earth's surface and the atmosphere is driven by the sun's energy. So to get it all to start, we need that energy from the sun that comes through as radiation. So it has all of these different components within the water cycle: evaporation, transpiration, condensation, and precipitation. So I want you to remember our little hand signals that we did. So that would be evaporation, condensation, precipitation, runoff. So evaporation, it was when liquid water is heated by the sun's energy and it changes from a liquid to a gas. That gas would be water vapor. And when that, we know from convection that hot gases and liquids rise. So thinking back to that, water vapor will rise. As it rises, it's going to cool and turn back into liquid water, which is forming clouds. That's condensation. And then precipitation, when clouds get heavy and the water falls to the ground, that precipitation that falls back to Earth's ground is going to be in rain, sleet, snow, or hail, or sleet, or freezing rain even. That's all precipitation, and it's all going back into that piece of the water cycle. But I want to spend a moment on transpiration. It's very similar to evaporation, but it's water evaporated from the leaves of plants. In third grade, you reviewed photosynthesis and knowing that that plants absorb water, and a part of that is released back into the atmosphere through transpiration as the water within the plants evaporate and turn into water vapor and go into the atmosphere. Matter, again, is anything that has mass and takes up space. Physical properties. This is important because this was very the hard pieces of within our review EOG. Physical properties is a feature of matter that can be observed or measured. So you can see it or measure it with tools. So color, you can see. Smell, you can take that in. You can use your senses. Taste, ability to conduct heat, like when you do heat transfer. Temperature can be measured. Texture, you can feel it. Sounds, you can hear. Magnetic properties, ability to dissolve, so like salt water, the salt dissolving in it. So, or a state of matter. A chemical property is a property of matter that cannot be observed without changing the matter, so whatever it is, into something else, like the ability to burn or ability to rust. It's changing. Like a physical property change would be like, or a physical change would be like tearing paper, but a chemical property would be burning paper, because once that paper's burned, it's not paper anymore. It's changed its property. But tearing paper, it's still paper. A physical change is a change in which no new material forms. It happens when one or more physical properties are changed. So like cutting paper, folding paper, coloring paper, drawing on paper, changing states. So like solid, liquid, gas. That would be like water. It's still water. It's just changed to a solid, liquid, or gas. A mixture is a matter made up of two or more materials. Objects are mixed, but nothing new forms, like salt water. It has a mixture of salt and water, but nothing new forms. It's still salt water. Chemical change, a change in which one or more new types of matter form. So signs of a chemical change: new materials form, a change of color, gases are given off. So like new materials, if we do that one review question that goes over when it asks for the different properties, and the answer we discussed was burning of firewood, it's because when that wood burns, it becomes like ash. It's changed its property. It's no longer wood. But a physical property would be like cutting wood. If you cut it into smaller pieces, it's still wood. Heat energy is the energy of moving particles. Heat transfer is the movement of heat, and transfer is a synonym for movement. So our three types of heat transfer are conduction, convection, and radiation. So conduction is the transfer of heat through things that are not touching. It uses a convection current. Hot liquids and gases rising, cold sinking. Rewind, I totally messed that up. So conduction is the transfer of heat through things that are touching. So conduction is through that direct contact. Convection is the transfer of heat through the movement of liquids and gases. So that hot air or water rising and cool sinking, that constant flow through a convection current. Radiation is the transfer of heat by electromagnetic waves. So you're going to think sun or fire. It's giving off some kind of light, and that is your source of heat through those electromagnetic waves. Just like in the microwave. If you did not have the light, those waves would not work. It would not cook your food. The sun, as you feel it on your back, that's all forms of radiation. Think of what is its purpose in here. Is it to give off light? Is it to heat the air or the water? Or is it objects touching to transfer heat, to figure out the difference between each one? What are you being asked? What is it asking? Okay, so that's the end of video 1, and we will resume with weather conditions and patterns shortly. Thank you.